Hello friends, I welcome you in lecture number 19 on Laplace transform. In this lecture we will talk about inverse Laplace transform. Inverse Laplace transform is the reverse of Laplace transform, or we can say that it is the inverse of Laplace transform, like differentiation and integration. We know that if derivative of some function fx is say gx, then this fx is the integral of function gx. So as differentiation and integration are inverse processes of each other, same thing is for Laplace transform. So we suppose we have Laplace transform of some function f of t equal to capital F of s, then this small f of t is called inverse Laplace transform of this function capital F of s, and it is denoted by L inverse of capital F of s. So these two processes are inverses of each other. We can have this type of picture to understand. Suppose here I have function of t in one set, and in another set suppose I have functions of s. So Laplace transform is converting function of t into function of s, and what inverse Laplace transform does is it is converting function of s into function of t. So both are inverse processes of each other, or if capital L is the Laplace transform, L inverse is the inverse of the Laplace transform. So we can easily find out inverse Laplace transform of a function if we know that that function is Laplace transform of which function. Suppose we want to find out inverse Laplace transform of s minus 2. Suppose function f of s is s minus 2, and we want to find out inverse Laplace transform of this function. Then we will think that this function is Laplace transform of which function, and we know that Laplace transform of e raised to 2t is equal to 1 divided by s minus 2. Therefore inverse Laplace transform of 1 divided by s minus 2 is nothing but e raised to 2t. So all the formulas which we have discussed for Laplace transform, we will reverse all those formulas and we will obtain the corresponding inverse Laplace transform formulas. We know that Laplace transform of 1 is 1 by s. Therefore from this we obtain the formula for inverse Laplace transform of 1 by s, which is 1. Similarly, we know that Laplace transform of cosine function cos at is given by s divided by s square plus a square. Therefore L inverse of the function s divided by s square plus a square is equal to cosine of at. So we don't have to remember all these formulas. We remember all these Laplace transform formulas, and using this definition we can easily write down the corresponding formula for Laplace inverse Laplace transform. If Laplace transform of small f is capital F, then L inverse of capital F, which is a function of s, is small f of t. So we reverse all those standard formulas which we have discussed in earlier lectures. So here I have written the list of formulas for Laplace transform, inverse Laplace transform, formulas for inverse Laplace transform. So we know that Laplace transform of e raised to at is 1 divided by s minus a. Therefore this e raised to at is the inverse Laplace transform of 1 divided by s minus a. So we obtain this corresponding formula for L inverse of 1 divided by s minus a. Similarly, Laplace transform of 1 is 1 by s. Therefore L inverse of 1 by s is 1. Laplace transform of cos at is s divided by s square plus a square. Therefore inverse Laplace transform of this function s divided by s square plus a square will be cos 80. Laplace transform of sin 80 is a divided by s square plus a square, and we can transfer this constant a on the left hand side. So this we can rewrite as 1 by a times Laplace transform of sin 80 is 1 divided by s square plus a square. Now using linearity property, we can take this constant in the division of sin 80. So this I have rewritten as Laplace transform of sin 80 divided by a equal to 1 divided by s square plus a square. So from this I obtain the formula for inverse Laplace transform of 1 divided by s square plus a square, and it is sin 80 divided by a. So therefore we obtain this formula, L inverse of 1 divided by s square plus a square is equal to sin 80 divided by a. For suppose I am interested in the L inverse of 1 divided by s square plus 9, then I will compare this with 1 over s square plus a square, and I can see that a square is 9, therefore a equal to 3. So using this formula I will write sin 3t divided by 3. So L inverse of 1 divided by s square plus a square is sin 80 divided by a. Similarly, we know this formula, Laplace transform of cos hyperbolic 80 is s divided by s square minus a square. Therefore L inverse of s divided by s square minus a square will be cos hyperbolic 80. And Laplace transform of sin hyperbolic 80 is a divided by s square minus a square, and if we transfer this a in the division of this sin hyperbolic 80, then we have formula for L inverse of 1 divided by s square minus a square equal to sin hyperbolic 80 divided by a. Also we have seen this formula, Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1. And suppose I am interested in the L inverse of 1 divided by s to the power n, then I can replace n by n minus 1 in this formula, so that I will obtain s raised to n here. So if I replace n by n minus 1 in this formula, I will have Laplace transform of t raised to n minus 1 equal to n minus 1 plus 1, that is gamma n, divided by s raised to n. This is constant, so we can transfer it on the left hand side, and using linearity property we obtain that Laplace transform of t raised to n minus 1 over gamma n equal to 1 divided by s raised to n. So from this we see that inverse Laplace transform of 1 divided by s raised to n will be equal to t raised to n minus 1 over gamma n. For example, suppose I am interested in the inverse Laplace transform of 1 over square root of s, then here power of s is 1 by 2, so I will take n equal to 1 by 2 in this formula, and I have t raised to 1 by 2 minus 1 divided by gamma 1 by 2, 1 by 2 minus 1, that is t raised to minus 1 by 2, gamma 1 by 2 is square root of pi, and this t raised to minus 1 by 2 can be rewritten as 1 divided by t raised to 1 by 2, and t raised to 1 by 2 means square root of t, so we have 1 divided by square root of pi into t. L inverse of 1 divided by square root of s is obtained using this formula by taking n equal to 1/2 and considering gamma 1 by 2 equal to square root of pi. We know that value of gamma 1/2 is square root of pi, so that we have substituted. And we know that if this n is integer, then gamma n will be equal to n minus 1 factorial. So if n belongs to n, then L inverse of 1 over s raised to n will be equal to t raised to n minus 1 as it is, but gamma n will be equal to n minus 1 factorial if n is natural number. So these are the formulas for inverse Laplace transform. So this is all about this session. In this session we have discussed inverse Laplace transform, and we conclude that if Laplace transform of f of t is capital F of s, if L of f of t is capital F of s, then L inverse of capital F of s is f of t. So we can reverse all the formulas from Laplace transform of f to L inverse of capital F of s, and we will use all these formulas in upcoming lectures as we proceed further for inverse Laplace transform. We will discuss all those results: first shifting theorem, multiplication by t raised to n, division by t, Laplace transform of integral of a function. We will reverse all those formulas one by one, and we will discuss problems of finding inverse Laplace transform related to all those formulas one by one, as we have done for the case of Laplace transform. So in this lecture we have just reversed all those standard formulas for the Laplace transform. We have written these 7 Laplace transform formulas, and then we have obtained the formulas for inverse Laplace transform. Okay, fine. So I stop here. Thanks for watching.